Ayan. All right. Hello, everyone. I'm back. So, um, I really hope you like my videos, my previous videos, and if so, please do show some love and affection by keeping the ads on and clicking the like and subscribe button as well. So for tonight, or maybe for today, we'll continue our learning together as we look into the different aspects of uh, entities. All right. Okay, moving on to the next. Okay, let's switch the screens right there. Okay, okay, entity aliases. So that's the first term. Um, the generic term entity can go really by other names. So the most common is entity type. So on screen we see here entity type example, as a type of something is being represented. So for example, Jane here in the screen is of type employee. Okay, therefore, Jane is the entity and employee is the entity type. So, however, in widespread use today is using the term entity for employee and entity instance for Jane. Okay, this you see the second row here. Um, Once again, the term entity is referred to as for the employee, and then while for the entity instance, it's for Jane in our example. Okay. Now, entity instances are the occurrences or values of a particular entity. Now, the entity student may have multiple student instances with names such as Bob, Jones, Joe, Jackson, James, Smith, um, Juan de la Cruz, and so forth. Now, the entity course can have instances of data modeling fundamentals, for example, advanced geology, English literature in the 17th century. So, entity aliases can also vary based on scheme. Now, perhaps schemes will be discussed in a separate video, not in this video. Now, in relational schemes, the term entity is often used. Okay, in dimensional schemes, the terms dimension and fact table are often used. And in object-oriented schemes, the terms class or object are often used. Now, in time, these are used in time-based schemes. They use the terms hub, okay, satellite, and link. Those are the ones that are often used. And in NoSQL schemes, the terms such as document or node are used instead. Now, entity aliases can also vary based on level of detail. Okay, the three levels of detail to be discussed later on, uh, perhaps in a separate video. Okay, but for now we'll stop on that part. Okay, now an entity at the conceptual level can be called a concept or term. An entity at the logical level is called an entity, or a different term depending on the scheme. And at the physical level, the terms vary based on database technology, and the most common term being table. Now, for the graphical representation of entities, now that you see in data models, entities are generally depicted as rectangles on screen. Okay, or rectangles with rounded edges with their names inside. So where there are three entities you see here, we have the student, we have the course, we have the instructor. All right. Now, by definition, entity definitions are really essential contributors to the business value of any data model. They are core metadata. High quality definitions clarify the meaning of business vocabulary and provide rigor to the business rules governing entity relationships. They assist the business and IT professionals in making intelligent business and application design decisions. Okay, high quality data definitions basically exhibit three essential characteristics. Now, what are those? Um, we look at clarity, the first bullet here. This refers, well, it can refer to the definition should be easy to read and grasp. Simple, well-written sentences without obscure acronyms or unexplained ambiguous terms, such as sometimes or normally. Okay. Now, accuracy. This pertains to the definition is a precise and correct description of the entity. Definitions should be reviewed by experts in the relevant business areas to ensure that they are accurate. Okay, now last bullet, we have completeness. All of the parts, what this means is all of the parts of the definition are present. So for example, in defining a code, perhaps examples of the code values are included. In defining an identifier, the scope of uniqueness is included in the definition. Okay, now when we start talking about a relationship, what do we mean by this? A relationship is an association. It's not here anymore, perhaps right here. Exactly. So this is an association, relationships, or a relationship is an association between entities. Okay, a relationship captures the high level interactions between conceptual entities, the detailed interactions between logical entities, and the constraints between physical entities. All right. Now, how about relationship aliases? The generic term relationship. This can go by other names, basically. Relationship aliases can vary based on scheme. And what we learn in relational schemes, the term relationship is often used. Dimensional schemes, the term navigation path is often used. And in NoSQL schemes, the terms such as edge or link are used. So for example, those are just a few examples, okay? And then what we'll further learn is relationship aliases can also vary based on the level of detail, okay? A relationship at the conceptual and logical levels is called a relationship. But a relationship at the physical level may be called by other names, such as constraint or reference, depending on the database technology. Now, if you look at here, the graphical representation of relationships. Relationships are shown as lines of data on the modeling diagram. Okay. Um, in this example, what we see here, the relationship between a student and course, this captures the rule that a student may attend courses. The relationship between instructor and course captures the rule that an instructor may teach courses. The symbols on the line, let's observe the symbols on the line. They are called cardinality. They capture the rules in a precise syntax. So perhaps we'll discuss this later on in a separate video. A relationship is represented through foreign keys in a relational database and through alternative methods for NoSQL databases, such as through edges or links. Now, we touched already about the high-level meaning of relationship cardinality. What about relationship cardinality? Now, in a relationship between two entities, cardinality captures how many of one entity or entity instances participates in the relationship with how many of the other relationship. Cardinality is represented by the symbols that appear on both ends of that relationship line. Data rules are specified and enforced through cardinality. So without cardinality, the most one can say about a relationship is that two entities are connected in some way. So for cardinality, the choices are simple. Yeah, zero, one, or many. So each side of a relationship can have many combination of zero, one, or many. Many means could be more than one. So specifying zero or one allows us to capture whether or not an entity instance is required in a relationship. So once again, let's repeat that. Specifying zero or one allows us to capture whether or not an entity instance is required in that relationship. So specifying one or many allows us to capture how many of a particular instance participates in a given relationship. Okay. Now this cardinality symbols on screen that we see here, they are illustrated in the following information. Um, Example of student, engineering example of student and course. All right. The business rules are each student may attend one or many courses. And the second one that of the business of the second business rule is each course may be attended by one or many students. Okay. Um, we'll touch a little bit on arity, but not too detailed because we don't have a lot of time left. Arity of relationships. The number of entities in a relationship is the arity of the relationship. So the most common one we have unary, or what we refer to as recursive relationship. We also have binary. We also have tertiary relationships. But in the interest of time, we'll not cover those examples here. After tackling about those concepts, we'll touch base with the what the foreign key is defined, how it's really defined per se. And we'll also cover attributes again and identifiers. No, I think this is the first part of the attributes and identifiers. And under identifiers, there's many other um, subtypes, you could say that. But for now, we'll stop on this video and we'll continue on the next. And thank you so much for taking the time watching this video. Thank you so much. And please don't forget to like and subscribe to my video as well. And of course, share it as you please. Thanks so much and have a great day there. Bye-bye.